The functional group that's an alcohol has a general structure that is an oxygen with 2 lone pairs on it and then a hydrogen. So the oxygen with its lone pairs are the site of a chemical reaction. This is the condensed structural formula. Remember, R means the rest of the molecule. And this alcohol group that is a hydroxide, you recognize the hydroxide polyatomic ion. This alcohol group, which is also called a hydroxide or a hydroxyl group, this hydroxyl group, OH, is part of the molecule, but it's the most important part. It's where the reaction happens. So the rest of the molecule is usually going to be hundreds, if not thousands of carbons, but this is an example with just 1 carbon. So remember, 1 carbon has to have 4 bonds coming out of it. So this is going to be a carbon with the OH, and then the other bonds are to hydrogens. So this is the structure of CH3OH. For a molecule that has the alcohol functional group, the IUPAC name ending will have OL, or alcohol. Everyday chemistry that you would have heard of is ethanol. Because of the OL name ending, it means that there's this functional group, this OH group is present.
Here's the condensed structure. This is the OH group. It's attached to the rest of the molecule, and this highlights that the oxygen has a bent structure, so that's the V shape. Now this structure is important, but it's really more important that this is a different atom. It's an oxygen instead of the rest of the molecule, which is a bunch of carbons and hydrogens. But this will impart a chemical function, as well as a physical function, being a different shape here. So this is the ethanol that I just mentioned. Ethanol is used in a lab as an organic solvent to clean things, and ethanol is also more popularly known in alcohol. So these bottles of alcohol, that general name alcohol is because of ethanol in there. So ethanol is also present in gasoline. The special E85 gasoline is 85% of ethanol, this molecule. Now, this molecule has the OL ending, which means that there's this OH alcohol group there, so we can see that in the structure. And from the prefix eth, that is ethane, the alkane that has 2 carbons. So there are 2 carbons in the structure of ethanol, and the rest of the atoms are those hydrogens, so that every carbon has 4 bonds coming out of it. We've also seen this glycerol molecule in the triglyceride. So glycerol has the name ending OL. When there's the name ending OL, that means that there's an alcohol group. And in fact, there are 3 alcohol groups. There are 3 OH groups on the glycerol molecule. The rest of the glycerol molecule, in the line angle drawing, there's 1, 2, 3 carbons, and then the remaining hydrogens, so that all of the carbons have 4 bonds coming out of them. But what's important in the glycerol are these 3 hydroxide groups, these 3 OH groups, or now we're calling them alcohol groups.
The ether functional group is an oxygen atom, and remember, oxygen can form 2 bonds, and there are 2 lone pairs on the oxygen. So those lone pairs of the oxygen atom are the site of a chemical reaction. And the oxygen atom on either side of it is bonded to carbons on either side of it. And so it's somewhere in the middle of a hydrocarbon chain. And so it doesn't have to be smack dab in the middle, but it just means that there are carbons on either side, or the rest of the molecule surrounds this ether functional group. So R means the rest of the molecule. And this is an example of the smallest possible molecule you can have with the ether group. Here's the oxygen with 1 carbon on either side. Drawing out the structure, the oxygen has 2 bonds, 1 on either side. 1 bond is to a carbon, the other bond is to a carbon. And in order for carbon to have 4 bonds coming out of it, the remaining 3 are to hydrogens. So this is 3 more hydrogens on each of the carbons. so that the carbon has 4 bonds. And so this is the condensed structure, CH3OCH3, and this is the structure. When there is an ether group, so this is the presence of an ether group, or when you have an oxygen, the name ending is going to be ether. Ethers are not so common in everyday like alcohols are, but ethers are very common in industry as solvents. And in medical history, it used to be used as an anesthesia.
So ethers mean that there's this oxygen with a bond on either side to the rest of the molecule, and this shows the bent shape around the oxygen molecule. So this imparts not only the chemical function that the lone pairs will allow, but also a structural difference having that bent shape compared to the rest of the molecule. This is the structure of the simplest dimethyl ether, and this has a carbon on either side. This is diethyl ether, and diethyl ether was used as an anesthetic in early medicine. It was called just ether, but this is the structure of what was used for anesthesia. And so it's not used anymore. There are more sophisticated anesthetics, but this was decades and primarily in the Civil War in the US for anesthesia for surgery. So this is an ether group right here. You recognize it as an oxygen with bonds on either side. This is the carbon is shown here, and this is in the line angle drawing. There would be a carbon here. This is also the ether group, and this is a carbon on either side. This is shown as CH3, and then this would be a carbon in this angle. Ethers are compounds that typically are gases or volatile. So inside of this can of diethyl ether is a liquid, but it is something that probably has a low boiling point, which means that it might be a boiling point that's room temperature and can become a gas without even heating it. So just being in the room means that this liquid will become a gas, and these gases are usually volatile and explosive, so they're stored under specific conditions. You can see from this warnings on the label. So in this quote by Nikola Tesla, who you know from Tesla cars, he was prominent in early electricity, but all matter comes from a primary substance, the luminous ether. This also was an understanding that ethers are gases, so they're small molecules that are easily gases in the air. If you've heard of Ethernet, which is the Wi-Fi connections go through an Ethernet into the larger network, the Ethernet was named after this concept of a luminous ether, that we have gases that propagate through the air that we can't see. Well, the Ethernet is transmission of something we can't see. It's data. So we can't see the transmission, we can't see the data, but we know it goes from computer to computer, or computer to router, or router to printer, but we cannot see any of that happening, just like we couldn't see the ether gases in the air.